Okay, we're going to start off our section on counting, learning the fundamental rule of counting. So the fundamental rule of counting says given two trials, if the first trial can have m number of different outcomes, and the second trial can have n different outcomes, then together the two trials have m times n number of outcomes. So this rule is really helpful for finding the number of items in your sample space. And normally when we're doing probabilities, that's the denominator of our probability. So number one says use the fundamental counting rule to find the total number of outcomes for flipping two coins. Well, flipping the first coin, we would have two outcomes, either heads or tails. And flipping the second coin, again, we'd have two outcomes. So there'd be a total of four things, four outcomes in our sample space. So rolling two dice, well, for the first die, there would be 6 outcomes. For the second one, there would also be 6. So there would be 36 total outcomes. Flipping a coin and then rolling a die, well, flipping a coin would have 2 outcomes. Rolling a die would have 6, so we'd have a total of 12 outcomes. So here, number 2 tells us that we can extend the fundamental counting to more than 2 trials. So you will just multiply however many different things you have. Find the total number of outcomes for randomly guessing the 10-digit PIN number of a friend. So let's assume you can use any number, so that means there's 10 different digits available for each spot. So randomly guessing a friend's 4-digit PIN, well, the first number would have 10 possibilities. The second number would have 10 possibilities. The third number would have 10 possibilities, and the fourth would have 10. So we'd have 10 to the fourth, or 10,000. Okay, similarly, number 3 says, given the newer Ohio license plates have 2 letters followed by 3 digits followed by 2 letters, what is the probability that a random Ohio car has the license plate HC290LB? Okay. So the letters, there's 26 letters in the alphabet, so each place we have a letter, we'll put 26. And there are 10 digits. So if we do 26 times 26 times 10 times 10 times 10 times 26 times 26, we get 456,976,000. It might just seem like that's a big number, but that would be an important number to know if you wanted to know, will this way that we make license plates give us enough license plates for the number of drivers that we have? So picking this one specific license plate, the probability would be 1 over the total number of license plates, which is what we just found. 4, 5, 6, 9, 7, 6, 0, 0, 0. So if you were just randomly to pick a license plate, you'd have a very, 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 very small probability of choosing that exact one. Okay, now we're going to talk about another operation that's called factorials. So factorial, the notation is an exclamation point, and a factorial means the product of decreasing positive whole numbers. So when we say 3 factorial, we mean 3 times 2 times 1, which we see in this case would give us 6. When we say 7 factorial, we mean 7 times 6 times 5 times 4 times 3 times 2 times 1, which you could multiply it out. But let's also talk about how to do that on our calculator. So we're going to put a 7, and then to get the factorial, we're going to hit math, go over to the letters PRB, that stands for probability, and choose number 4. So 7 factorial, we see, is 5,040. We could do 5 factorial. So hit 5, again go math, over to PRB, and down to the factorial. We get 120. Now it's important to know that 0 is a special case. 0 factorial is just equal to 1, which I know doesn't make sense if you just think about it, but there are many places in our formulas where we would need to divide by 0 factorial, and if it was 0, that would mess everything up. So statisticians have defined 0 factorial to be equal to 1. So just remember, on the calculator, you're going to go over to math. Sorry, you're going to hit the math button. You'll use the arrows to go over to PRB, and then you'll choose number 4, which has the exclamation mark. Okay. Now the factorial, so a collection of n different items can be arranged n factorial different ways. So if you have a bunch of things and you want to know how many you could arrange them, you can use the factorial function. So number 1 here says, how many different ways could you go to McDonald's, Taco Bell, and Dairy Queen? So this is 3 different restaurants. So they can be arranged, or the fancy word here is permuted, in 3 factorial different ways. So if we do 3 and then go math over to PRB and choose number 4, we see there are 6 different ways of the orders that we could go to those 3 restaurants. So different ordering or arrangements are called permutations. So if you want to take statistics, English, computer, and science, how many different ways could you take these 4 classes? Well, that would be 4 factorial. So we'd have 4 times 3 times 2 times 1, which would give us 24 permutations. Now, what if you only wanted to take 3 of the 4 different classes? How could you take 3 of those classes? Well, we'd start off, you'd have 4 choices for the first class, 3 choices for the second class, and 2 choices for the last class. So 4 times 3 times 2, again, would be 24. Because whatever that last class would be would be given. So another way that you could say it is, how many different 4-letter words could you make from the letters Walt Disney? Now, if you count them, count the letters, there are 10 different letters here. So if we just randomly chose one, there would be 10 choices for the first letter, 9 choices for the second, 8 choices for the third, and 7 choices for the last one. And if you do 10 times 9 times 8 times 7, you get 5,040. So doing that, the probability of randomly choosing the word Neal, N-E-A-L, well, that's just one of the words over a total of 5,040. Now, these permutations come up a lot, and so they actually have a special rule. And so if we select R items without replacement from a group of N items, the number of permutations can be found dividing by n factorial by n minus r factorial. So you'll see this NPR. So this is, if you have n objects, the number of ways to permute r of them. The formula is n factorial over n minus r factorial. Now on our calculator, we'll be able to go to math and then go over to PRB and then choose number 2, and we'll be able to do permutations. So here, if we have 5P5, n would be 5 and r would be 5. So we'd be doing 5. On the calculator, it'll say NPR, and then we'll do 5 again. So you're going to put your first number in, and then you'll hit math, go over to PRB and choose number 2, and then put your second number in. So here we get 120. For the second one, we have 4P3. So n is going to be 4. and then we're going to hit math, go over and put 3, and we get 24. For 22p5, our n is 22 and our r is 5. So again, we can use our calculator. So again, what that number means, it means if you had 22 objects and you wanted to know how you could arrange 5 of them, well, we just found out that there's 3,160,080 ways to arrange them. So number 4 here says we have 20 students in the class. How many different ways can we choose 5 students to be class president, BP, treasurer, social coordinator, and tutor? So 5 different jobs. So another way of saying this is how could we arrange the students in that order? President, VP, treasurer, social coordinator, and tutor. So this would be 20 because there are 20 students total, P5. So 20 P5, and we would get 1860480. So over 1.8 million ways to choose that. And the really important idea is that with permutation, the order matters. So here we're saying the order that we pick the students, if we're going to pick president first and then VP, treasurer, matters. So another way you can see this is if you have a number of things and you want to know how many different routes you can take. So number 5 here says a new author would like to set up book signings in a major city of each state, but she only has time to visit 5 states. How many possible routes could she take? So this would be 5P, and she's visiting all 5 states. So 5P5, which is actually the same as 5 factorial, which we've seen is 120. So there'd be 120 different routes she could take.